Hello, everyone, and thank you for joining me. Today, I want to talk about one of the fundamental challenges our data-driven economy is facing. And the challenge is that data-driven organizations or data-driven enterprises, in order for them to go to the next level or the next evolution in the way that they create value and utilize the data they have to start breaking down the data silos and work on the data in a collaborative way. When I talk about data silos, I mean data silos within organizations, I mean data silos between organizations, or data silos between countries. Any of these scenarios that we can bring more data together and combine data sets from multiple organizations will enable this data-driven world to continue to evolve. However, at the same time, this need to collaborate or share data immediately runs into challenges and barriers around protecting the data or the privacy of the data, or even simply protecting the business value, the business secrets that organizations have within their data. And so this challenge, on one hand, to enable the data world to continue to move forward, at the same time, protect the privacy of the data or the business value in the data is the challenge I'm talking about. And that's why I founded Duality with my co-founders to go and really resolve this problem and enable the world to apply data science in a collaborative way and in a much more responsible way. Before I move on, I want to share a little bit on a personal side how I got into this field and why I'm so passionate about it. So I'm what one would call a data geek. Understanding how this box on our shoulders, how our brain has been working, was something that fascinated me always. And so it's no surprise I went and I done my PhD in computational neuroscience. And it's a fascinating field, but the two main insights I took away from that period is really two interesting topics. One is that our brain, or more correctly, our neocortex, has the same operating system, same hardware, no matter what we're talking about, no matter if it's a sensoric cortex, if it's our motoric cortex, if it's our language areas, all our brain areas are very similar in the way the hardware is built and the same way as the operating system works. And the value, the learning, the way we learn patterns, remember patterns, and so on, is created from the connectivity and the collaboration between our different neurons. So we have like about 100 billion neurons in our brains, and the learning is actually the connections between them. Some of you may be familiar with the term neurons that fire together, wire together. That's how we learn. So in an IT kind of way, one could say that no matter what our brain does, no matter what use case it's trying to solve, we have the same operating system, the same hardware, and the value is created from the connectivity and the collaboration between neurons. In parallel to my PhD, I actually done my MBA and have served in the last 20 years as what one would call today a data scientist. Originally, we called it the data mining, then we called it machine learning. Today, the field is called data science. And I worked in this field in healthcare organizations, in marketing organizations, in financial organizations. And eventually I was the chief data scientist of RSA, the security company. And once again, the two main learnings are, one is no matter what problem you're dealing with, the tool set, the mindset, the way you operate and drive data science projects is very, very similar. It's not dependent on the use case. And the other thing is that the value of the data, not the quantity of the data, the value of the data, the ability to bring rich data from multiple sources is key for the success of the data science projects. I'll just give you an example. When I was at RSA leading data science, one of the products we had there was a system to do online learning to detect fraud, the financial fraud. And we were lucky enough to have a system that could collect data from multiple banks and really learn the fraud patterns from multiple banks. And I can tell you that you could use the most simplistic and simple machine learning model if you apply it to data coming from multiple banks, from multiple fraud patterns, the outcome, the value of the model is way, way, way more efficient than if you use the most sophisticated machine learning model, but on data from one bank. So once again, this concept that you have a unified set of tools or unified way to do the data science projects, and the value comes from the ability to connect data sets from different types of domains or different types of customers or different types of countries is what really creates the value. And this is actually at the basis of what I truly believe is the next frontier in this world of utilizing data. It's around our ability to collaborate and work on data, but we have to do it in a much more responsible way and really protect the data while we're analyzing it. So let me talk a little bit about now how the data world evolved, how the enterprise world evolves, and how we have to really address this challenge of collaborating in a private manner. So looking at it from the data point of view, if we look back at the last 30, 40 years at the evolution of not actually the data, but how you utilize data, is 30, 40 years ago, the world was obsessed about collecting data. It was all about taking data, putting it in a digital form and saving it. That was like the golden age of the databases. A few years went by, and then companies said, well, great, now we have all the data. How do we create value out of it? And that's when the BI, the business intelligence kind of community started, and BI companies were created around it. And the goal was basically to look at the data you have and see different patterns in it, typically historical patterns. A few years evolved and companies said, great, now it's good that we can see backwards what's happening, but let's start looking to predict the future. Let's try and use our data in order to predict the future or make better decisions. And this is really the wave where machine learning or AI came in. And that's also where many, many machine learning and AI companies have been created. And their goal basically is really to drive better decisions and drive revenues for companies. This is also the place where data-driven enterprises started to utilize these kinds of tools to really create much more value. And the fourth wave, where we stand today, is really what I call the collaborative data science world. It's not only working on the data that is in your possession, but actually working on data in a collaborative way, combining data from multiple sources, some of them even competitive. And the minute you create this kind of ability to collaborate on sharing data, you can drive much, much more value. And I don't think in today's era, after 2 years of the COVID pandemic, anyone would question that if the world could have combined the data of the pandemic earlier on, we could have identified trends much quicker, or we could have maybe came up with better protocols for vaccinations and so on. So this ability to collaborate on data is, of course, a well-known property. If we look at the second, this is the way that the data evolved and is required to now collaborate on data. If we look at it a second from the enterprise world, so although we had this last 3-4 decades around data, it's only in the last decade that we see data-driven enterprises emerging. And data-driven enterprises are enterprises that use data science across the organization to drive better products and revenues. These are typically organizations that don't have data science as a center of excellence, but data science is embedded throughout the organization, and the data science, the chief data officer has a seat in the board table, and there's a clear strategy around how these companies utilize data. And if you look today at the biggest companies in the market, it's not a big surprise. These are all data companies. But the modern data-driven enterprise is an enterprise that has to collaborate on data and use its data better, break down these silos, connect its data to within the organization, across borders, and between organizations to drive it. But also we live in a world, and good for us, that you have to do this in a responsible way. the modern data-driven enterprise has to use its data in a responsible way. And in order to do this, there's a whole family of technologies today called PETs, privacy-enhancing technologies. And the goals of these technologies is actually to go and enable organizations to work on this data in a collaborative way without really ever disclosing the data. Now, there's many PETs around, and a lot of the companies in the world are asking actually what PET is best. What privacy-enhancing technology should we be using? So there's basically 5 main types of PETs, type of privacy-enhancing technologies in the world. We're not going to go over them in depth, but each of them has a different kind of property. For example, synthetic data is actually taking real data and simulating it. This obviously has a lot of advantages because the data stays in its original format. But if you're trying to predict, for example, cancer for a patient, you definitely can't synthetically create that patient or the data of the patient. Federated learning is this ability to run as much as possible of the machine learning cycles at the edges and only combine some insights. That's very effective if there's a lot of data that's distributed across multiple entities and that you're basically trying to do what's called horizontal federated learning and not link the data before you analyze it. There's other solutions like trusted execution hardware, which is secure hardware environments to analyze the data, differential privacy that adds a kind of a noise to the data. And of course, maybe the holy grail of this field is this ability to analyze data while it's encrypted. So to apply computations to the data while it's encrypted. And the question many people and many organizations, and have been asked again and again by even board level members, is what PET should we be using? Which of these PETs, which of these technologies is the right one to use? And not surprisingly, the answer is that you have to use the right PET for the right job. So I want to now walk you through in a little bit more detail, what do I mean by the right PET for the right job? Or what types of job require what types of PETs? And I want to do it by looking at the world a second from a data science point of view. Some of you may be familiar with this data science life cycle, which is basically describes how a data science project looks, from defining the problem to really creating the data set, normalizing it, preparing it, cleaning it, through taking the data and applying to different statistics to learn properties of the different features in the data, throughout the actual modeling of it to predict something, and then putting the model into production. And without going too much into detail, here are a few questions that you can focus on later. But if you are, for example, doing the data normalization or data collection and data cleaning part, in many cases, the accuracy of the computation is less critical. You just mainly want to understand what types of features you have, where you have missing values, and so on. In that case, solutions like synthetic data may be ideal to start off with. In cases when you want to do the data exploration, where you want to start to run different types of statistics or correlation between the features, it really differs. If you're doing what's called, for example, horizontal linking, which is combining data set from multiple data owners, but at the same data types or the same features exist all over, and you bring in the data to the center to enlarge your cohort, or what's called data or linking, vertical linking, where the different data owners each have a different property, different features of the same customer or patient or record. So one is like a union and one is like a join. This obviously differs. If it's more a union kind of thing, federated learning can work very well. If it's more a join kind of thing, you have to use technologies like encryption or morph encryption, multi-party computations, and so on. And when you come to model, of course, it depends the type of the model, the sensitivity of the model, the complexity of the model, and the holy grail may be that you do this whole cycle in order to use your model in production. And then again, if you're trying to predict, for example, a cancer, you have to do it on the exact data set of the patient. So then you have to use solutions like encryption. But if your model just runs aggregated statistics on large enough data sets and the accuracy is not so important, you can use synthetic data. If the model itself can reveal something, you may have to overload the differential privacy on top of it. So the different problems from different angles have different reasons to use different pets. I want to just like walk you through a little example. Let's say you're trying to build a personalized healthcare application for a consumer. Let's say we're trying to build a better diet for this guy. So obviously, ideally, you would like to combine data from gyms around fitness and wearable data and clinical data and the genomic data of the person and even eating habits, and really combine all of this to come up with maybe the best kind of diet plan. In order to do this, you have to go through all the steps we described before. So for example, in generating the data in order to do your machine learning, you first have to collect data from multiple, let's say, wearable sets. So just understanding what data you have in which wearables, how to normalize it, what are the distributions, that's a classical thing that maybe synthetic data could help you do. However, when you want to maybe model something like understanding how different fitness programs impact your blood pressure, for example, you may want to do this in a federated mode where you're doing all the computations on the edges and only combining the computation at the end. And of course, if you want to start to link all these data sets on a personal level, so for the same patient, the fitness program, the eating habits, the wearable data, the genomic data, clinical data, you have to combine all of this on a single record. A, it has to be accurate. B, you can't do it in a federated way. And in this case, you would have to use methods like homomorphic encryption to do this computation. So this is just like a simple example of different technologies you need in different stages of the project in order to come up with, at the end of the day, a better solution that can combine data from multiple sets. And also I have to say, it's not clear cut. Some of these technologies can do more than other things, but each one of it has its clear sweet spot. So the question we should be asking ourselves is not what pet is best, it's actually what pet to use when. And of course, each pet has its own kind of properties, and what you really want is this kind of animal or platform. You want a solution to be as strong as a horse, as quick as a cheetah, and protective as a dog. And you don't want to take a dog and train it to run as quick as a cheetah or whatever. So this is the concept that Duality is pushing, this idea that all these privacy-enhancing technologies are great. The different technologies are used for different problems. There's different security levels that we haven't spoke about that are part of the mix. And the idea is that you want to go and build a platform that can solve the problem you have with the right technologies. So what Duality is promoting is not looking at this world from a privacy-enhancing technology point of view, but looking at it from a privacy-enhancing platform point of view that enables you to collaborate. What you see here is just one dimension of the problem, looking at it according to where the data is actually distributed. Is it in one center place, or is it distributed? Are you required to link the data horizontally or vertically? And here you see how we use the different technologies for the different use cases. And of course, there's other views and ways to look at it. A lot of the other dimensions are actually the security dimension. These different types of pets have different security measures. Nevertheless, the whole idea is really providing a platform that has the right solution for the right problem. Duality typically operates in the financial space and in the healthcare space. And the reason we got to this concept of a platform is that we typically work with our customer on one problem and then find ourselves adding more and more of our capabilities to solve other problems. Very much like the data science world operated in the past, where you solve one problem and then you start to use the same platform, the same tools to use other solutions. And these are some of our partners and the problems that we solve in the financial space. And similarly in the healthcare space, we work with multiple centers to do things like GWAS, genome-wide association studies, or real-world evidence studies, where all of these things are at the end of the day around the ability to collaborate and work on sensitive data and derive value out of it. So to summarize, in order to enable the world to move towards what we call a modern data-driven enterprise with a responsible data strategy, you have to find a way to A, collaborate on the data, and B, make sure that you protect the privacy or the business value within the data and not exposing it. And that's exactly what Duality brings to the market. I want to add by just summarizing three of the main concepts. So the first concept is that in this data-driven economy, and organizations that want to stay data-driven organizations, they have to move to the next level, which is this ability to collaborate on data, to break down data silos and work on the data in a collaborative way. That's where the exponential value will be created out of the data. And that's where the data strategies will really jump to the next level. At the same time, the conflict with privacy and the conflict to protect your data is not going anywhere. So you have these two things and they're conflicting, and you have to come up with this data privacy concept when you're trying to derive this exponential value. And the way to do this, the way to build the solution, the way to build your data strategy in a responsible way is to use a multi-pet platform. Take all these technologies around privacy enhancing technologies and really combine them in a platform and utilize this platform to solve your problem. And I assure you that the world will stop looking at this from a question of what is the right pet and what is the best pet, to a place where what is the right pet to do the right job, and what platforms in terms of total cost of ownership and usability you should be using to solve your problem. What else I want to add and offer you to reach out to us if you trying to build your data strategy around the need to analyze sensitive data, or thinking on how you can collaborate in a privacy enhancing way, or even simply trying to understand what pets do you need, how do you buy them, what is the cost associated with them. Please reach out to us and we'll be happy to get back to you. Thank you very much.